Hi everyone. Today let's talk about session 10.3, Calculus in Polar Coordinates. So this is the last session in our course. Big idea. Finding the slope of tangent lines and area squared by a curve and the length of a curve defined in polar coordinates requires slightly different formula than when we have for y equals f of x. Big skills. You should be able to calculate the first derivative of graph defined in polar coordinates, the area swept by an arc defined in polar coordinates, and the area of the closed curve, and the area between two curves, and the outlength of a closed curve. So let's review. Remember, we have three important applications. That is the derivative, area, and outlength. And the old formula for functions, area. So derivative, we have f prime is dy dx. Area is the integral f of x dx. That is the same as, because f of x is y, that's the same as the integral, the definite integral from a to b of y dx. Then the outlength is integral from a to b square root of 1 plus the derivative square dx. Okay, so that's our old formula. And then in session 10.1, when we learned about the parametric equations, we have the formulas associated to it. So the derivative is then, because x and y, they are functions of t, so the derivative is y prime of t over x prime of t. Okay, and then the area now becomes integral from alpha to beta. Those are the t values, and then we have y of t and then x prime of t dt. And for the outlength, we have the integral from alpha to beta, square root of x prime of t square plus y prime of t square. Okay, so that is the formula for parametric equations. So today we're going to learn a new set of formulas for polar coordinates. Okay, so let's see. So given a polar curve r equals to a function of theta, so theta is the independent variable and r, the distance from the point to the origin, is a function of the theta. Okay, then by change the variable, we know x equals to r cosine theta, because r is f of theta, so we have x equals f of theta cosine theta, and y equals to f of theta sine theta. Well then, what's dy dx? Because they are both function of theta, so you remember that is y prime of theta over x prime of theta. Well, y prime of theta, well, we're going to differentiate this guy, right? But this is a product, so we use product rule. The derivative of the first guy times second guy, sine theta, plus f of theta times the derivative of sine, which is cosine. Okay? So we use product rule here. And then the denominator, we have x prime of theta. Well, that is also a product rule. The derivative of the first guy, which is f prime theta, times cosine theta, minus f of theta. Derivative of cosine is negative sine, so you have negative sine theta right here. So I don't memorize this formula. I know dy dx is y prime of theta over x prime of theta, and then I can use the product rule to deduce this formula when I need it. Okay, so that's why here, just remember derivative is y prime of theta over x prime of theta, and when we need it, we can use product rule to derive it. Okay. And then slope of a tangent line, let f be a differentiable function at theta 0, and then the slope of the tangent line to the curve at the point f of theta 0, comma theta 0. So this is in polar coordinates, right? This is r, this is theta, polar coordinates. And then it's the derivative, we plug in the theta 0, okay? Provided the denominator is non-zero at the point. And angle theta 0 for which f of theta 0 equal to 0 and f prime of theta 0 not equal to 0. Okay, the tangent line is theta equals to theta 0 with the slope tangent theta 0. Okay, What does that mean? Okay, so angle theta 0. So at the angle theta 0, let's say this is theta 0. Okay, for which f of theta 0 is 0. Okay, so this guy, f of theta 0 is 0, and f prime theta 0 is not 0. In that case, when we plug in it, this is 0, so this guy is gone. And then you can see, because this guy is not 0, so they cancel out. Then we have tangent theta 0 over cosine theta 0. So that's why we get the slope is tangent theta 0. Okay, that is the special case. So we can calculate it at that time. Okay, so let's look at example 1. Find the slope of the tangent lines to the circle r equals to 10. Okay, so let's see. Well, dy dx equals to, because r equals to 10, then we have x is 10 cosine theta and the y is 10 sine theta. Okay, and dy dx then is y prime of theta over x prime of theta. Okay, let's differentiate y prime of theta. Derivative of 10 sine is 10 cosine theta. And then derivative of 10 cosine theta is 10 negative sine theta. Okay, so here we're differentiating. Okay, and you can see 10 and 10 cancel. Cosine over sine, that is cotangent. Okay, so the slope is negative cotangent theta. And that's the slope, right? And this is the circle, so we can draw the picture. So this is a circle with radius 10, and at each theta, let's say here, this is the theta, then the slope here, the slope is negative cotangent theta. Okay? Alright, so that is it for example 1, okay? Because we're looking for the slope of tangent lines, and we didn't have a specific angle theta, so we get it's a function of theta. Alright, let's continue. Example 2. Find a point on the interval from minus pi to pi at which the cardioid. Okay, so this picture is the cardioid. R equals f of theta equals 1 minus cosine theta has a vertical or horizontal tangent line. Okay, vertical tangent line, well, look at the picture. Vertical tangent line looks like this 3 points, right? Horizontal tangent line looks like is this 2 points, right? Okay, so let's find this. So we have r equals to 1 minus cosine theta, and x is r cosine theta, which is r times 1 minus cosine theta. So far, so good, everybody? And so what is that? Well, that is r, okay, sorry, r is 1 minus cosine theta. So 1 minus cosine theta times cosine theta. Okay, so that is the x. If you want to simplify, you can distribute it. Then we have cosine theta minus cosine theta squared. Okay, so that is the x. For the y is r sine theta, so we have 1 minus cosine theta times sine theta. Well, that is, when we distribute it, we have sine theta, and then minus cosine theta times sine theta. So far, so good, everybody? Alright, so what is dy dx? Y prime of theta over x prime of theta. Y prime of theta, let's take the derivative of y with respect to theta. Derivative of sine theta is cosine theta. And then derivative of cosine and sine, that is the product rule. So that is, okay, let's make a parenthesis there. So derivative of the first guy times second guy plus the first guy times the derivative of the second guy. Okay, And then the denominator derivative of cosine is minus sine, and derivative of cosine squared. Well, that's chain rule, okay? So it's 2u, derivative of u squared is 2u times u prime. All right, let's continue. So we have cosine theta minus derivative cosine is minus sine. So let's also get rid of the parentheses. Okay, so minus become plus. So plus sine theta times sine theta is sine squared. And then next, distribute negative plus become negative. Derivative of sine is cosine. So cosine times cosine is cosine squared. Well, the denominator, we have negative sine theta minus derivative of cosine is negative sine. So minus become plus 2 cosine theta sine theta. Okay, and then let's see. We want to, so this is the derivative, right? In order to get a vertical tangent line, we set the denominator equals 0. In order to get the horizontal tangent line, we set the numerator equal to 0. So let's see here. Okay, so let me write it down. So vertical tangent line that corresponds to the denominator equals to 0, okay? And horizontal tangent line that corresponds to the numerator equals to 0. Okay, the denominator equal to 0, we have negative sine theta plus 2 cosine theta sine theta equal to 0. Let's factor it. When we factor the sine theta, then we have negative 1 plus 2 cosine theta. Well, this guy, we get sine theta is 0. Well, what does sine looks like? Well, this is sine, right? And remember now, we restrict our theta to be between minus pi to pi. So from minus pi to pi, what angle give us theta? Sine theta is 0. Well, theta is a negative pi and 0 and pi. How about this guy? We have negative 1 plus 2 cosine theta equals 0. So 2 cosine theta equals to 1. Cosine theta equals to 1/2. Okay, so what is cosine theta? So what's the picture of cosine? So this is sine. So this is cosine. So we're looking for 1/2, okay? 1/2 right here. This is pi, this is minus pi. Okay, what angle give us 1/2? Well, that is pi over 3 and minus pi over 3. So theta equals to minus pi over 3 and pi over 3. So far, so good, everybody? Okay, so let's see. If theta equals to minus pi, what are the points? Okay, so what are the points? Well, if theta equals to minus pi, then r is 1 minus cosine theta. So cosine minus pi is negative 1. 1 minus negative 1 is 2. Wow, that corresponds to, let's see, minus pi is this guy, and you go to 2. So this is the point it corresponds to 2. So far, so good, everybody? And next, when we plug in 0, 1 minus cosine 0. Cosine 0 is 1. 1 minus 1 is 0. Oh, okay. So that corresponds to the origin. Oh, okay. Let's see. And when we plug in pi, cosine pi is minus 1. We also get 2. So actually, this guy and this guy corresponds to the same point. Okay. And And how about when theta equals pi over 3? Well, cosine pi over 3 is 1/2, right? And then 1 minus 1/2 is 1/2. So pi over 3 is like here. So it corresponds to that point. Okay, and the minus pi over 3, we have cosine minus pi over 3 is also 1/2. So 1 minus 1/2 is also 1/2. So that corresponds to this point. Let me use more colors so you can see the difference. Okay, so this guy and this guy, we are this point. And this guy, they are this point and this point. So far, so good. And the 0, 0 is the origin. Alright, so let's continue to the other half, okay? So what points do we have a horizontal tangent line that corresponds to the numerator is 0? Okay, so the numerator is 0, we have cosine theta plus sine theta squared minus cosine theta squared equal to 0. So here you can get rid of the sine, or you can get rid of the cosine. But because you have cosine theta and cosine squared, so maybe it's easier to get rid of the sine because we have two terms consist of cosine. And think about it, what's sine theta squared? Well, that is 1 minus cosine squared. So plug in here. Okay, so we plug in, we get cosine theta plus 1 minus cosine theta squared minus cosine theta squared equals 0. Well, that's the same as cosine theta plus 1 minus 2 cosine theta squared. I would like to reorder it, and I want to make the leading coefficient to be positive. So I reorder it, and I multiply by -1 on both sides. So, and then I have negative cosine and minus 1. Alright. And then, so see, now we want to solve. This is like a quadratic equation, right? We can try to factor it. Let's see whether we can factor it. So I can put 2 cosine, -1. Oh, so I can do -2 and +1. That would give me -1. Great. Then this guy give us 2 cosine theta plus 1 is 0. Cosine theta is -1 over 2. And what is the cosine value? Give us -1/2. Alright, let's look at this picture. So -1/2 is here. Okay, so that is -3, theta is -2 pi over 3, or is positive 2 pi over 3. Okay, and this guy, cosine theta is 1. Okay, when will give us cosine theta is 1. So that is when theta is 0. Okay, remember theta is between minus pi and pi. Okay, so when theta is -2 pi over 3, let's plug in r. R is what? R is 1 minus cosine theta. And cosine -2 pi over 3 is -1/2. So 1 minus -1/2 is like 1 plus 1/2. So 3/2. And same thing when we plug in 2 pi over 3, cosine of 2 pi over 3 is -1/2. So 1 minus -1/2 is 1 plus 1/2 is also 3/2. Okay, so what are these? They actually correspond to this point, right? You see this angle is 3 pi over 2, and this point, this angle is 2 pi over 3, not 3 pi over 2. Okay, and we still have one value. Okay, so when theta is 0, okay, so the angle is 0, cosine 0 is 1. 1 minus 1 is 0. Do you see this point 0, 0 appear in the, what color that I haven't used? Let me see. How about yellow? Okay, can you see this guy here and here? What does that mean? It looks like we have a vertical tangent line there and horizontal tangent line there. It's actually not. It means at that point, we actually kind of stop there. We don't have any direction, so no tangent. The tangent line is not defined. Okay, so here, the point is kind of, so it's like when you go over this graph and when your point is like from minus pi to pi, right? So you go around this graph, and then when you travel at 0, 0, the point is kind of stop there. Okay, stop there for maybe a second or what, and then so the velocity, so stop at the origin, so the velocity at the origin is 0, okay, is 0 at that moment. Okay, so yes, this is the velocity. You can think about the velocity is like when theta is 0, this is 0, okay, at that point. And so that's why the tangent line is not quite defined there. Okay, so that's why when they ask you find the points such that the cardioid has a vertical or horizontal tangent line, you're gonna exclude the points 0, 0 in both cases. Okay, so tangent line not defined there. Okay, because the derivative does not exist. It's also does not exist because sometimes does not exist. It could be like we have a vertical tangent, but in this case is the point is like stop there right at that moment. So we don't have a direction. Okay. All right, let's continue. Area. So area of regions bounded by polar curves. In this session, we developed the formula for area of a region whose boundary is given by a polar equation. We need to use the formula for the area for a sector, okay, of a circle. Okay, so how do we derive this formula? Well, you have a pizza, right? And you want to make a quarter of it. Okay, so you know that total area of the circle is pi r squared, right? And then you think about, okay, this portion, so this pieces is like how much portion of a circle? Well, if this is theta, the whole circle, the angle is 2 pi. So the portion is theta over 2 pi, okay? That's the proportion of the circle times the area of the circle, then that is the area of the sector. Okay, you can plug in some angle and try to see whether it's true. Okay, for example, this piece is like theta is pi over 2, right? When you plug in pi over 2 there, pi over 2 pi, well, 2 cancel, you get 1 over 4, right? So the proportion is 1 over 4. So we get 1 over 4 pi r squared, and that match. Okay? And so here where the r is the radius and theta is the radian measured of the central circle. Okay? Let R be the region bounded by the polar curve, R equals to f of theta, and by the rays, theta equals to A, and theta equals to B, where f is the positive continuous function and where b minus a is between 0 and 2 pi. Okay, so this is the picture. What do? Well, we don't divide it into a rectangle, right? We divide it into so we're going to divide the theta A and B into subintervals with endpoints, and we're going to divide these pieces into sectors, right? So we have this picture. Okay, And each of them, the angle we have equal with change of theta. So if we choose theta I in the ith subinterval from theta sub I minus 1 to theta I, then the area of the ith region is approximately by the area of the center of the circle angle change of theta and the radius f of theta. Okay, so you can see here the change. The change is, the angle is like change of theta, and the radius is f of theta I. So that's why the area of sector here, we have 1/2 change of theta r square. Okay, but you always put change of theta at the end. And then we sum all of those sectors. So that's why when we add the angles to infinity, we get the Riemann sum. This sum becomes the integral, and then we have 1/2 r squared. So r is f of theta, and then the change of theta, delta theta, becomes d theta. Okay, so this is the formula of the area, okay, in polar coordinates. Well, if you have two graphs, f and g, well, then you just use the outer area minus the inner area. Okay, it's like how do you calculate the annulus? Well, you use pi big R squared minus pi small r squared, right? So here, similarly, you use 1/2 f of theta squared d theta. That is the outer area, and then you subtract 1/2 g squared d theta. That's the inner area. Okay, so this is the formula. Couple of things, be careful. Well, for our regular function, for the area, you usually use f minus g, but here is square. So don't forget the 1/2 and don't forget the square. Okay, everybody? All right, so let's okay, let's put it down in our table. Okay, so I hope this table, as a comparison, you can like get better to compare them, and then hopefully you won't get confused by many formula. Okay, so here let's say theta is between alpha and beta, and then we have 1/2 r squared d theta. So r squared, which is f of theta squared d theta. So far so good, everybody? Okay, so if you have another function, you just put parentheses and then you subtract g of theta squared. Okay? All right, let's continue. Okay, so find the area of the 4 leaf rows. R equals to 2 cosine 2 theta. Okay, so first of all, let's plug in some angles. Okay, if angle, where is theta equals 0? Well, cosine 0 is 1, so 2 times 1, 2. So at this point, we have theta equal to 0. How about when theta equals to pi over 2? Well, cosine of pi over 2 times 2 is what? Pi over 2 times 2 is pi. Cosine pi is -1. And so we get -2. Oh, so when the angle is pi over 2, the r is -2. So -2, so you go backwards. So actually here, this guy corresponds to pi over 2. Okay, how about pi over 4? Okay, yeah, so we want to figure out how these points travel. So how about pi over 4? Well, cosine pi over 4 times 2 is pi over 2. Cosine pi over 2 is 0. Like cosine looks like that. Cosine pi over 2 is 0, so we get 0. So at pi over 4, r is 0, so we actually get the origin. Okay, so we get the origin. Let me use a blue so you can see. Okay, so how do this guy travel? It starts with theta 0 and then it travels Okay, and then when it passes the origin, it travels here, and it goes here, and then hopefully you can see it goes here, here, and here, and there. Okay, so that's the trajectory of the graph. Okay, so can you see this guy is symmetry? It's a lot of symmetry. So we can calculate the area of this blue area, these pieces, and then the total, how many copy of that? 4, 8. So 8 copy of that, right? So our area is 8 copy of the blue area. The blue area is correspond to the angle from 0 to pi over 4. Okay, so in the final exam, the graph is given like this picture. You don't need to plot the graph, but you need to be able to identify, okay, where is the point when theta is 0? Where's the point when theta is pi over 2? And sometimes, if your pi over 2 is right here, then you want to maybe decompose the angle more, like where's pi over 4? Okay. And then, we use our formula is 1/2 r squared. Well, r is 2 cosine 2 theta squared d theta. So far, so good, everybody? Okay, let's see what it is. Let's so expand it. We can move the 2 out. So 8 over 2 is then 4. And then 2 squared is 4, and then we have cosine squared 2 theta. Okay, 4, we can also pull it out. We have 16, 0 to pi over 4, cosine 2 theta squared. Yeah, in this chapter, you're going to use trig identities and double angle formula a lot. Do you remember when we have even power of cosine? What do we do? Do we do U substitution? Nope. We only do U substitution if the power of sine or cosine is odd. Okay, one of them is odd. But here we have even power, then we use the double angle formula. So what is cosine square? So cosine square, don't use theta, let's use t. What is that? 1/2 plus 1/2 cosine 2t, right? And sine square is 1/2 minus 1/2 cosine 2t. So you can see which one do we use? The top one, right? We want to decrease the degree and double the angle. So now cosine 2 theta square is 1/2 plus 1/2. When you double the angle, what do you get? It was 2 theta. So when you double the angle, it becomes 4 theta. And you can see we can pull out the 1/2 in front. 16 over 2 is 8. Then we have 1 plus cosine 4 theta. So let's integrate that. Integral of 1 is theta. Integral of cosine is the derivative of sine is positive cosine. So integral of cosine is sine. But you gotta divide it by 4 in front. And then evaluate from 0 to pi over 4. Okay, so we plug in pi over 4 first. And sine, pi over 4. So pi over 4 times 4 is pi. What's sine pi? Well, sine pi is actually 0. And then when you plug in 0, they're all 0. Sine 0 is 0, right? So that's why 8 pi over 4 is just 2 pi. Oh, so the area of this 4-leaf rows is 2 pi. A nice number. It's the same area as the angle. The circle with radius square root of 2. So far, so good, everybody? Alright, so that is example 3. So let's do more exercise. Consider the circle r equals to 1 and the cardioid r equals to 1 plus cosine theta. Part A, find the area of the region inside the circle and inside the cardioid. Well, inside the circle and inside the cardioid, which is this piece. Okay, part B, find the area of the region inside the circle and outside the cardioid. So part B is like here. Oh, can you see the part A and part B? They're all together. They are the area of the circle. So once we get the area of part A, then we can use the area of the circle, subtract part A to get part B. Okay, so let's figure out the part A. Let's figure out the part A. Well, can you see here? This guy. So this guy is actually half of a circle, right? We know what is half of a circle. So it's enough to just calculate this piece, right? We calculate this piece. And then the bottom one will be this guy will be the same as the top one, and then we add half of a circle, then we can get it. Okay, so let's plus some points. Okay, so what's this guy? Well, this guy, it looks like the angle is pi over 2. Let's plug in pi over 2 into our cardioid. Cosine pi over 2 is 0, right? Cosine, what's cosine looks like? Cosine pi over 2 is 0. So when we plug in pi over 2, we get 1. Oh, this is like the point. So we know that this point corresponds to theta equals pi over 2. Okay, how about that point? When we plug in pi, cosine pi is -1. 1 plus -1 is 0. Oh, the origin. The origin corresponds to pi. Okay, and when you plug in theta is 0, cosine 0 is 1, so we get 2 right there. Okay, so what is the purple area? Okay, so the purple area equals to the integral, the angle is between pi over 2 to pi. And the formula is 1/2 r squared. R is 1 plus cosine theta squared d theta. Okay, so let's calculate the purple area. Well, let's move the 1/2 in front. And then let's multiply it out. We have 1 squared, which is 1, plus 2 cosine theta plus cosine theta squared d theta, right? We're using the formula 1 plus b squared. A plus b squared is a squared plus 2ab plus b squared. Okay, and here, can we integrate 1? Yeah. Can we integrate 2 cosine? Yeah. How can we integrate cosine squared? Well, that's the double angle formula we just used. You see, we use a lot of double angle formula in this session. So cosine squared is 1/2 plus 1/2 cosine 2 theta. Okay, so we place that here. So this 1/2 and that 1/2 we can combine together. So that becomes 1/2 plus 1 is 3/2. And then we have 2 cosine theta, and we have the 1/2 cosine 2 theta d theta. So far so good, everybody? Okay, we can then integrate it, right? So we have 1/2 integral of 3 over 2 is 3 over 2 theta. Integral of cosine is sine because the derivative of sine is cosine. Integral of cosine, so it's sine 2 theta, but you need to divide it by 2, okay, in front. Evaluate from pi over 2 to pi. So that means we plug in pi first. We plug in pi, 3 over 2 pi. What's sine pi? What's sine? What's sine? Sine looks like this, right? So sine pi is 0. Sine 2 pi is also 0. Ooh. Subtract when we plug in pi over 2. When we plug in pi over 2, we get 1 half 3 over 2 times pi over 2. And then plus sine of pi over 2 is 1, so we have 2. And sine of 2 times pi over 2 becomes sine pi is 0. Okay, so we get 3 pi over 4 minus the 3 pi over 8 minus 1 half times 2, which is 1. Oh, 3 pi over 4 minus 3 pi over 8 is 3 pi over 8 minus 1. So that is the purple area. So far, so good, everybody? Okay, so now what is the area in part A? Well, the area in part A is 2 copy of the purple area, which is 3 pi over 8 minus 1, plus area of half of a circle. So 1 half pi r squared, the r is 1. So, just 1 half pi. So 2 times that, so it's 3 pi over 4 minus 2 plus pi over 2. Well, we can combine the pi together. So pi over 2 is like 2 pi over 4. 3 plus 2 is 5 pi over 4 minus 2. Okay, so this is the answer in part A. How about part B? So part B is the area of the circle with radius 1, which is pi r squared, r is 1, pi minus the area in part A, which is 5 pi over 4 minus 2. Well, negative 2 become positive 2, and then pi minus 5 pi over 4 is negative pi over 4. Okay, so that is the answer for part B. So far, so good, everybody. So the picture will be given in the exam. So what you're gonna do is just identify the points and set up the integral. Okay. So in the final exam, you have a 1 problem out of 10.1. So 10.1 we have 3 applications. Derivative, area and out length, you have 1 of those 3, but I won't tell you which one. So you gotta prepare one of them. Okay, and you will have 1 problem in session 1.3 corresponds to so it's 1 of the 3 types, derivative, area, and out length. Okay, 1 of them, but I also won't tell you which one, so you gotta prepare. So 1 problem in 10.1, okay, parametric equations, okay, those 3 applications, and 1 problem in 10.3, polar coordinates, and those 3 applications. Okay, all right, let's continue to look at example 5. Find the area of the inner loop of r equals to 2 plus 4 cosine theta. Okay, so here I give you the angle as well. So this guy corresponds to the angle 2 pi over 3, okay? And that guy corresponds to the angle 4 pi over 3. And so this guy is you can use is the area from 2 pi over 3 to 4 pi over 3. Okay, but can you see they're actually symmetric? Yeah, so that means, by the way, when you plug in theta is 2 pi over 3, what's cosine 2 pi over 3? Cosine 2 pi over 3 is right here. So you get minus 1 half. So 4 times minus 1 half is minus 2. 2 minus 2. So you get 0. That's why you get the origin. And then when you plug in pi, cosine pi is what? cosine pi is -1. So 2 minus 4 is -2. That's why this point corresponds to the angle pi. Okay, so instead of calculating the area from 2 pi over 3 to 4 pi over 3, I can do 2 copies of the angle from 2 pi over 3 to pi. So that corresponds to this piece. So I can calculate the area of this piece, and then it's easier. Because cosine pi is the values is easier when you plug in 4 pi over 3. So far, so good, everybody. So that's why continue 1/2 r squared. So 2 plus 4 cosine theta squared. And you notice that at the pi, because your r is negative, but because you square it, even though the r is negative, it's okay. You still have a positive area. So unlike the our usual definite integral, if the function is above the x-axis, we get a positive area. When the function is below the x-axis, we get a negative area, and the net area is the definite integral. So sometimes the positive area can cancel with the negative area. But for the polar, you can see because square is always positive, so you always get positive area. Okay. Oh, you see what is good? The 2 and the 2 and the 2 and the 1/2 cancel. Oh, that's nice. And then 2 plus 4 cosine theta squared. Let's multiply out. So it's 2 squared plus 2ab. So 2 times 2 times 4, which is 16 cosine theta. And then plus 4 squared, which is 16 cosine theta squared, d theta. So far, so good, everybody. And what is the same thing? Cosine squared is 1/2 plus 1/2 cosine 2 theta. So that is integral 2 pi over 3 to pi. When you multiply by 16, what do you get? Well, 16 cosine theta squared is then 8 plus 8 cosine 2 theta. So the 8 you can combine with the 4 right here. Okay, so that will give us 12 plus 16 cosine theta, and then plus 8 cosine 2 theta d theta. Okay, integral of 12 is 12 theta, integral of cosine is sine, and integral of cosine is sine, but you gotta divide it by 2. Evaluate from 2 pi over 3 to pi. So we plug in pi first, it's 12 pi, and sine pi is 0, sine 2 pi is 0. See, that's great. So we use the pi to plug in. Okay, many things is zeros. And then we plug in, so 0, and then we plug in 2 pi over 3, so 12 times 2 pi over 3, and we have 16. What is sine of 2 pi over 3? Well, 2 pi over 3 is actually root 3 over 2, right? Plus 4, sine of 4 pi over 3. So 4 pi over 3 is right here. That corresponds to negative root 3 over 2. So far, so good, everybody? Alright, let's see. So 12 pi minus this is 24 pi. Oh, we can cancel. So this guy cancel, we get 4. So 8 pi. And then minus. So what do we get here? So 16 minus. Okay, let me do it slowly. So this is like a square root of 3 minus 2 square root of 3. So that is 4 pi minus 6 square root of 3. Okay, so this is the area of the green spots. Okay, And the total area, I mean, because we already multiplied by 2 copies at the beginning. So far, so good, everybody? Okay, so that is how to compute the area. The last application, odd length of polar curves. To find the length of a polar curve, r equals f of theta between a and b. And then by change of the variable, so we know x equals to r cosine theta, so that is f of theta cosine theta, and y is r sine theta, which is f of theta sine theta. So remember now, r is a function of theta. So when you differentiate the xt theta, you're going to use the product rule, right? Product rule is derivative of the first guy times second guy plus first guy times derivative of second guy, but the derivative of cosine is minus sign, so you have a minus here. Derivative of y respect to theta is derivative of the first guy dr d theta times second guy plus first guy times the derivative of the second guy. Derivative of sine is cosine. Okay, and then we still want to use the O formula. So the O odd length formula is for parametric equation is square root of d x d theta square plus dy d theta square. Okay, just replace t by theta because they're both functions of theta. Okay, so what's the x d theta square plus dy d theta square? Well, we're gonna take this guy, square it. Well, this guy square it, what happened? Is the first term square, which is derivative of r respect to theta square, cosine square, minus 2 times both of them. So that's why we have 2r dr d theta cosine theta sine theta. And then plus the last guy square, which is r square sine theta square. Okay, so this guy together, it corresponds to dx d theta square. Okay, and then next, dy d theta square, okay, which is this guy squared, is the first term square plus 2ab, so 2 times the first term times the second term plus the second term square. Okay, so now what happened? Something fun happened. Cancellation. Yeah, this guy canceled with this guy. And can you see we can group this together? When we group this together, we get dr d theta square, and then we have cosine square plus sine square. Well, but that is 1. So that's why you only get dr d theta square. And for the r, this guy and this guy, we group them together. And we can factor out the r square, we get sine square plus cosine square. Well, but that is 1. So that's why you get r square. So at the end, the formula of the polar coordinate odd length is the square root of the derivative of r respect to theta square plus r square. Okay? So let's complete our table. Okay, so let's say if my theta goes from a to b, then this is the square root of dr d theta square plus r square d theta. So far, so good, everybody? All right, let's see how can we solve examples about odd length. Okay, so find the length of the curve r equals to theta. Okay, so let's see here. Here, so r equals theta, so dr d theta is just gonna be 1, right? And then r length is an integral of theta from 0 to 1, dr d theta squared, so which is 1 squared, which is 1, plus r squared. R squared is theta, so theta squared d theta. So far so good, everybody? Okay, and how do we compute that? Well, 1 plus theta squared inside the square roots. But first of all, we're not able to make a complete square about the 1 plus theta squared. So in this case, we actually need trig substitution. Yeah, this example is actually quite challenging. Okay, so trig substitution. But because we already have the theta, so let's use the angle BX. So 1 plus theta squared, well, that is the tangent, right? So yeah, our old setup is like x equals tangent theta because we were having an integral about x, but now we're having the integral about theta, so let x be the angle of the trig substitution. Okay, a kind of different notation with what we have done before, but it's like you just reverse the role, so exchange the roles of theta and x. Okay, and then the derivative of tangent is secant squared. And then who's the friend of tangent? Secant. So now what happened? Okay, so let's see. So integral of 1 plus theta squared d theta. Let's calculate the indefinite integral. So that is secant theta d theta, secant x. The angle is x. And we have secant squared dx. Okay? And so we actually have secant cube. Okay, what do we do this here? Well, if you can remember, we learned in session 7.2, we learned the integral about secant and tangent, the powers of products of powers of secant and tangent. The first case is whether the tangent power is odd. Second case, whether the secant power is even. But this is the third case, which is the hard one. So actually, how to compute this problem is, well, use integration by parts. Okay, so remember, we're gonna set up the u and dv. So you're gonna set this is the u, and you're gonna set up this is the dv because we're able to integrate the secant square. So integration by parts. Okay, so u is secant x, du is then secant x tangent x dx. dv is secant x squared dx, then v is tangent x. Okay, so that's why I call this integral I. Okay, let's call this integral I. Then I is uv secant tangent minus integral of v du. Okay, so we get this guy is secant tangent. This guy is tangent squared secant x dx. Okay, I don't know how to compute the integral of that. Oh, it's okay. You can kind of relate this back to the secant cube because what is tangent? Tangent is actually secant squared minus 1. So we multiply out. We have secant tangent and minus secant cube, and then minus become plus. Integral of secant x dx. Do you see now this is I? So we can move it on the left. So we get 2I equals to secant x tangent x. And what's the integral of secant? Well, we learned that in session 7.2. That's natural log of absolute value of secant plus tangent. Okay, and then finally your I is 1/2 secant tangent and ln of secant tangent plus c. Okay, but what is secant tangent in terms of theta? Well, remember tangent, so tangent x is theta over 1, so the angle is x. Opposite is theta, adjacent is 1, then the hypotenuse is 1 plus theta squared. Okay, so we get 1/2 secant. Secant is 1 over cosine, so hypotenuse over adjacent. Tangent is opposite over adjacent. And the square root of 1 plus the square plus that. Okay, so finally, our L, we can plug in. So is everything here? We plug in 0 and 1. Okay, so let's plug in 1 first. We plug in 1, we get square root of 2 times 1 plus ln of square root of 2 plus 1. And then minus plug in 0. Okay, the first term is 0. The second term is ln of... oh, I forgot to multiply by 1/2 here as well. So... okay, and you get ln of 1 is also 0. So this guy is gone. So our final answer is just like root 2 over 2 plus 1/2 ln of square root of 2 plus 1. So this is our final answer. Yes, so this example is quite challenging because it involved the polar coordinates, the trig substitution, and integration by parts, and the trig identities. Yes, so this example is quite challenging. Okay, so let's continue to look at example 7. Find the length of the cardioid r equals to 1 minus cosine theta. Okay, so dr d theta, derivative of 1, 0. Derivative of negative cosine is... so derivative of cosine is minus sine. So here negative become positive. So sine theta. Okay, so here you can plug in when theta is 0. We get cosine 0 is 1. 1 minus 1 is 0. So this guy corresponds to theta is 0. When theta is pi over 2, cosine pi over 2 is 0. We get 1. So this is pi over 2. And then when you plug in pi, cosine pi is negative 1. So we get 1 minus negative 1 is 1 plus 1, which is 2. So this guy corresponds to theta equals to pi. So I would say the arc length of everything, you can see the top and the bottom are the same. So we can calculate as 2 copy of the theta goes from 0 to pi. Okay, from 0 to pi. Now let's see, square root of dr d theta squared, which is sine theta squared, plus r squared, 1 minus cosine theta squared, d theta. Okay, so let's expand it and see what happens. So that is sine squared plus 1 minus 2 cosine theta plus cosine theta squared. Right? And so that is... we can combine the sine and cosine together. Sine squared plus cosine squared is actually 1. So 1, and we have another constant 1. So we get 2 minus 2 cosine theta. Ooh. So remember, when we want to solve the integral with square roots, we either use trig substitution, or there is a way that we can make a complete square inside the square roots. Okay, so here we have seen some example like this before. What do we do? Okay, so we want to create a complete square there. Well, remember, we have the double angle formula. Okay, so let me use T. Okay, I don't want to have a theta again. So, and we have 1/2 minus 1/2 cosine 2t. Okay, so here you can see which one we should choose. This one. And we want to have 2 layers, so we multiply by 4 on both sides. Okay, so now we can replace so theta is 2t, then t is like pi theta over 2. So 4 sine theta over 2 squared is 2 minus 2 cosine theta. Okay, let's plug in now. So we have 2 integral from 0 to pi, and then we have 4 sine squared theta over 2. Wow. What happened? So the square root and square root of 4 is 2. Square root of sine squared is actually absolute value of sine of theta over 2. But what's sine? Sine is this. When you can see when the angle from 0 to pi, theta over 2 actually becomes is between 0 to pi over 2. 0 to pi over 2, our sign is positive, so we can get rid of the absolute value. Oh, we can also combine the 2 and 2 together. That gives us 4. And then we have sine theta over 2. Alright, what's the integral of sine? Derivative of cosine is negative. So integral of sine is negative cosine theta over 2. And you divide it by 1/2. That's the same as multiply by 2. Alright, 8. We plug in pi first. Cosine pi over 2. Subtract negative, become plus. Plug in 0. Cosine, what's cosine looks like? Here. Cosine pi over 2 is negative 1. Negative 1 become 1. Cosine 0 is 1. Oh, so what happened? We get 16. So far, so good, everybody? Okay. Sorry, I just realized I have a small mistake. So cosine pi over 2 is right here. So cosine pi over 2 is not negative 1. Cosine pi over 2 is actually 0. So the answer is 8. Okay, so it's very important to check our work. Okay, so I hope you can check your answer again and again before you turn in your exam. Alright, so that is our last session. I will miss you a lot. If you have questions, please feel free to email me and ask me. Bye!